Hello, everyone. Today I'll be talking about some research that a few colleagues and I did looking at identifying drivers of vegetation conversion in Southern California. And so the research that we did was focused primarily on chaparral ecosystems, and these are characterized by evergreen shrubs that form these dense closed canopies like seen here. And these shrublands are adapted to Mediterranean climates, characterized by hot, dry summers and cool, wet winters. And then they're also fire adapted to the historic fire regime in Southern California of high intensity crown fires burning through the area every 25 to 100 plus years. However, there's been growing instances of type conversion of chaparral to non-native grasslands. And this is of concern because there's not only a loss of native biodiversity, but also a loss of important ecosystem services that chaparral provides, such as slope stabilization, habitat for animals and vertebrates, and carbon sequestration. And there's been many potential drivers identified at the plot level, like shortening fire return intervals, drought, and site aridity. But the research that we did really wanted to focus on identifying drivers at larger spatial scales. And so our research is focused on the 2003 Piru fire scar that's almost directly inland of Santa Barbara and northwest of Los Angeles. And we used 1930 historic aerial imagery and then more recent 2009 imagery to identify vegetation fluxes in this area. And our research sought to answer three main questions. The first being, how widespread is chaparral conversion to grass at a larger spatial scale? What is driving any observed conversion that we see? And how are different variables potentially interacting to drive that conversion? And so as far as the vegetation fluxes that we saw, we can see that in 1930, there is widespread dominance of chaparral in the area. By 2009, there's fairly substantial conversion to grasslands, leading to grasslands being almost equal in dominance to chaparral. And the drivers that we identified for this conversion, with this graph here showing variable importance and variables higher up on the y-axis being more important, we can see the southwestness with more southwest facing slopes generally being more exposed to sunlight during the day and more arid year round were more likely to convert. Plots that had less precipitation within the 4 years post-fire also being more likely to convert. And so here we see an interaction between drought and fire. And then plots that had higher grass cover in 1930 were also more likely to convert. And then plots at lower elevation and plots with shorter return intervals. And so here we see kind of this expected higher frequency of fire leading to chaparral conversion as well. And so going back to our questions, we can see that we did indeed observe widespread conversion of chaparral to non-native grasslands, that the drivers were post-fire drought, site aridity, grass presence, and short interval fires. And then we really saw a strong interaction between drought and fire compounding to make conversion more likely. And so we can really summarize our findings with this schematic here, showing that chaparral recovery after fire can be derailed and lead to type conversion by either a high presence of grass pre-fire, leading to pretty immediate conversion post-fire, drought events within the first 4 years of fires, leading to type conversion, or short interval fires within 5 to 7 years after a high intensity crown fire, also leading to conversion. Thank you for your time.